we begin our transition from, I'll just call it the first half. The first half of Unit 10, which was all about testing series, infinite series, to see if they converge or diverge. Now, we did a little bit with talking about the sums, but honestly, the sums, that is what we are interested in, because from the sums, we get mathematics with meaning. So we just spent a couple of weeks. You could argue wasting your time. I would argue not wasting your time. You learned lots of new things. You can argue about the interesting level of those new things, but nonetheless, you learned about many new things. And the purpose for those is going to be revealed in some sense as we transition into the next phase, the end of the unit, as well as finish up our study of infinite series for our purposes in calculus. So we begin by looking at this idea of absolute versus conditional convergence. So absolute convergence, that's when if you consider the absolute value of the series converges. Conditional convergence would be, well, we looked at the absolute value of the series does not converge. What happens if we just look at the series? If the series converges, we'd say the series converges conditionally. If we can't do that for either, we say that the series diverges. And this seems really, really strange, I think. But if we actually look at a few of these, I think that it will make some more sense. For example, we're going to look at 3 series together, and then you'll work on 2 series on your own. We're going to determine if the series converge absolutely conditionally or if those series diverge. So here's the first one. And you may recognize the bones of this first one because it has literally been our first series for almost every series test we've considered. So we begin by considering absolute convergence. Absolute convergence means I take this series right here. I take the absolute value of the nth term. And I write down the result. The result is 1 divided by n. So this then is the series I'm going to look at, and I'm going to consider the convergence or divergence of. We need to work on the lighting in here. Hopefully that's okay enough. So this is harmonic. It's not just harmonic, it's the harmonic series. So we know that the series diverges. Well, that's what I get for trying to be fancy, I suppose. Okay, so we know that the series does not converge absolutely. Okay, well, does the series converge conditionally? Let's find out. So what about conditional convergence? Conditional convergence means we go back to the original series and we check to see if this series, oh my, converges or diverges. So once again, we need to dial up an infinite series test. In this case, the alternating series test. How do I know it's the alternating series test? Well, because I know that the terms alternate signs. I determined that by considering some of the terms. I didn't write them out, but I just thought about it. Some of you may be at this point in your series testing, but if you're not, you're always welcome to write out a few terms. Okay, since I'm applying the series test, terms alternate signs. The limit as n approaches infinity of the absolute value of the nth term is 0. And the terms are decreasing. How could I know this? Well, if I look at this compared to this, we could try cross multiplication. I think you'd agree that n is always less than or equal to n plus 1. Well, note to self, I cannot write with this. Straight in the bin with that one. Garbage. I was lied to about the quality of these pens, or maybe I wasn't. Who knows? Okay. So absolute conditional convergence is something slightly new, but overall, I think it's a great chance for us to review all of our series testing skills. Here's another one. We are again going to look at whether or not the series converges absolutely, conditionally, or if both of those prove to be false, diverges. And it's really valuable, I think, for, again, our purposes of review here, to explore that. Because it allows us to think about not one, but two infinite series tests. So check this one out. When I take the absolute value, I am looking at this series. So how would you determine the convergence or divergence of this series? Let me pause the recording here while you think. Spent all that time considering, and you decided to do the ratio test. Why did you decide to do the ratio test? I don't know. I can tell you why I decided to do the ratio test. I thought the ratio test made the most sense here because I have a mixture of operations. So the ratio test is the limit as n approaches infinity of the n plus 1th term, which would be n plus 1 factorial divided by 2 to the power of n plus 1, divided by the nth term, which means I multiply by the reciprocal. And if I simplify, this equals the limit as n approaches infinity of the absolute value of, n plus 1 divided by 2. Check your algebra for the ratio test if you need to go back and look at that. Okay. So this is infinity. Infinity is bigger than 1. The ratio test tells me the series diverges. So we know that the series is not absolutely convergent. The question is the series conditionally convergent? The answer to that ends up being no, but let's find out why. Well, hopefully this is okay. Okay, so we're going to apply the alternating series test. How did I know to do that? Terms alternate. Okay, so let's consider the limit of the absolute value of the nth term. So we have n factorial divided by 2 to the n. Does that equal 0? It does not equal 0. How come? N factorial dominates 2 to the n. Series then diverges. Straight in the bin with that one. Okay. One more to try here together. Good time to pause. Okie dokie, last one. Infinite series. This is from n to n equals 1 to infinity. Shocking, I know. Numerator is -1 to the power of n. Denominator is square root of n. The directions are the same. We are again considering absolute conditional convergence. So in order to do that, we want to look at the series and determine if this series, when I take the absolute value of it, converges or diverges. So when I take the absolute value, we end up with this series. We're going from 1 to infinity, 1 divided by the square root of n. I'm going to pause here for just a few beats while you consider how you would do that. You would, of course, do this as a p-series. With p equals 1/2. So this series we know diverges. Pretty sure that's what that means. I don't know. Maybe I'm wrong. Maybe. Happens every now and again. Okay, so we know that the series does not converge absolutely. The question is, does the series converge conditionally? And in order to answer that, you may have noticed that we end up doing the alternating series test. Did you notice how we did it 2 times out of 2? We're about to do it 3 times out of 3. Hint, it's every time out of every time. Something to think about. Okay, so terms alternate signs. Again, if you're not comfortable just looking at something to say that, please write out the terms. N equals 1, I have -1 divided by square root of 1. N equals 2, I have 1 divided by the square root of 2, that's positive. N equals 3, -1 divided by the square root of 3, negative. N equals 4, positive 1 divided by the square root of 4 is 2, positive. Okay, alternate signs. So the question is, first, is this the case? As n approaches infinity, does 1 divided by the square root of n equal 0? It surely does. It takes a pretty long time compared to many of the other things we've studied, but that definitely equals 0. So, question, which is the case? I'm sorry, is it the case that this is true? Is the n plus 1th term less than the nth term? So I could get out my calculator. I could do some algebra, cross multiply, if that makes it easier to think about. I could say that since the square root of n plus 1 is a larger denominator, it's smaller. However it is you wanted to look at to say that this was decreasing. Hey, you could take the derivative. Ooh, let's do that. Derivative n to the -1/2 power is -1/2 n to the -3/2. How about that? that going to be negative for n greater than or equal to 1? It surely is. So a whole bunch of ways you could do that last part of the alternating series test. Either way, we determine that the series converges. So we conclude that the series converges conditionally. Gorgeous, just gorgeous. Okay. These ones are going to be yours. Take time to copy those down and write them out. I will pause the recording here. Just a quick check back to see how your work went. You'll notice for the second one, I did an abbreviated version of the alternating series test. I didn't really want to try to fit everything in. But the first one is absolutely convergent, and the last one that you did was conditionally. I'm sorry, was not absolute and not conditional, so it diverges.